today we are solving this problem. Flip columns for maximum number of equal rows. So you are given a m cross n binary matrix. Matrix has only zeros and ones. So you can choose any number of columns in the matrix and flip every cell. Flip in the sense whoever is 0 you can make that 1 and 1 to 0 in that column. Remember column, not row. Okay. So return the maximum number of rows that have all values equal after some number of flips. So using this column wise flip operation, if we can use that, we have to make the highest number of rows which can be the every element would be equal. So that is what we have to do. For example, you can take this one. So let me draw it here. So suppose our matrix is like this 0 1 and 1 and 0, right? So if I do a flip here, what will happen? It will make 1 1 like this, 1 1 and 0 0, correct? So in this case what happens? We got two rows equal, right? This row has all element equal, right? So one row is here, and similarly here also everything is 0. So another row we found. So total 2 rows we found, right? Just doing one flip for this column. Okay, so this is what we have to do. So this is one of the very simple example. We will take some other example as well. Okay, so for example, take in the question itself. So see here, this is 0 1 and 1 0. So 2 rows, we just took this example. Let's say this time we are taking 0 1 and 1 1. Okay, so this is like this. We are taking here 0 and 1 and 1 and 1, right? So if I do flip here, right, this what it will give? It will give 0 0 and 1 0. So see here, this row was already equal, but even after the flip operation, this equality of this was finished, and we got another. So even in this case we are only getting the one identical row, right? Even if we do the flip or we don't do the flip, right? So only one identical. Let's say if we are doing the flip, then we got this. If we are not doing any flip, then also we have this row as equal. So only one row is possible after doing flip. Okay, so see here, it is saying here, see, only one flip is possible. Okay, similarly we have many more examples. Now we will take one general solution for it. Okay, this is the what we have to do. Now the thing is how to do, because this is very simple example, just 2 rows and columns. What if there are huge number of rows, right, and multiple columns? Then how would we make sure that what would be the maximum number of identical rows after doing all those flip operations of column? Okay, so let's take one example which will give you a better understanding. Okay, so for example, if I am taking, let me remove all of these, just bear me for a second. Yeah, so now we will take a better example. For example, let's say I am taking, yeah, so suppose this is my 1 1 1 and 0. Okay, and then suppose we have 0 1 0 1 like that. Then we have, let's say, one more like this, 1 1 1 and 0. Now suppose we have one more row which is like 0 0 0 1. Okay, now we got this kind of matrix. Okay, so now you guys can observe one thing here. Okay, what is that thing? So did you notice here, this row and this row both are identical, right? For example, let me make the things simple. I'm removing this guy. Okay, let's say we have these 3 rows. Okay, so I'll add additionally, but let's say initially we have all equal rows. Okay, suppose we have this kind of matrix. So in this case you understood that if we do one flip, only one flip at this column, right, this will make us what? 1 1 1 1. We got one identical. Similarly value also 1 1 1 1. So you can clearly observe that if R1 and R2 are same, okay, if they all the flips or all the bits are same, then R1 and R2 are same. So only see here, if we do one flip operation, we can get how it would be. We can get 1 1 1 1, right? 1 1 1 and 1. Similarly here also 1 1 1 and 1. So that means one flip operation at this column we got the two identical rows just because these R1 and R2 are equal. Now consider there were another row called R3, okay, which is like this 0 0 0 and 1. So when we did this flip operation, right, we were doing this flip operation, so these R1 and R2 are equal and R3 is just the flip opposite of these two, right, wherever 1 we had 0. So that also, if we do the same operation, let's say if I'm doing this, anyway this will produce, I'm doing this flip operation at this column, okay, so anyway this is giving me 1 1 1 1, this also giving me 1 1 1 1. What I would be get here, I would be get 0 0 0 0, right? So this also becoming flip opposite, this also becoming an identical row, right? So in general I can say that if we can find out of this matrix, if we can find all those rows which are either equal like R1 and R2 plus those who are the flip opposite of those rows like this R3, this is flip opposite, if we flip them then we are getting. So these two types of rows can be accommodated in the similar kind of flip column wise operations. The operations could be 0 or more than that. There is no boundation on that column wise flip operation. So we can say that if we find in this matrix the rows which are identical, R1 equal to R2 plus those which are the flip opposite of it. So in this case, let's say now there could be multiple rows. There could be anything like 0 1 0 1, we don't care. But we are here interested only to get the highest number of this kind row like R1, R2 and R3 which are, so there could be multiple rows which are identical but we have to find the highest number of them. So identical and flip opposite. So in this example what will happen, there are two identical, okay, and one flip opposite of them, so 2 plus 1. So if we do we will find the 3 rows here, okay, which can become the identical after doing the flip operation column wise. So we should be clear now. Now the thing is like then how to solve it. We found the logic, but how to find it in a efficient way. So one way is like we can just use the for loop, go for every row and find its flip opposite and then check it, but that will take the complexity would be very high, even n cube, right, O of n cube. So we don't want, we want in a better way. So to get it in a better way, we have to look for certain things that what we can do. So you guys can observe one thing. So if our intention is to get the highest number of the identical and their corresponding opposite flip rows, right? So we can do one utility here. So see here, for whatever row we are starting, we can denote the first number of every row with certain value. Let's say I'm giving it t. For example, we are at R1, so first value is 1, so I'm giving it t, okay. This value, this whatever digit is first one, similar value we will repeat. So this guy also 1, so we will write it t, okay. This guy also 1, so we will write it t, okay. Now this one is 0, so we have to write for 0 f, okay. You can choose any value, but let's say we are taking these value. So t t t f. Now come to this row. So what is the first value? First value is 0. That means our t would denote, in this case for this row, our t would be 0. So let's say first it would be t in this case. Now in this case 1 would be anchoring for f, right? So t f and t f, because this is 0, so we'll write t, right? And this is final one is f. Similarly, now we'll come to here. So what will be here? So what is the t here anchoring for? T is 1. So we will put t here. This guy first. So another, this is 1 t. This is also 1. So we will write t was 0. So we will write f here. Got it? Now we'll come to the last one. So what is the t anchoring for? T anchoring for 0 now. So we will put here t. So what is the first character that would denote the t? So here 0. So t. This is also t. This is also t. Now final guy would be f, okay. Now you can observe one thing here. See, this is ttf, this also ttf, and this also TTF. So now you can guess here that all those rows which were equal and their opposite flip, they are basically producing the same number. See here, this is also producing TTF, which was the opposite flip of R1 and R2. And see here, this is also producing TTF. See here, this is also producing TTF, but this is different row side, so it is not producing, right? It is producing TF. So now our question is shortened to find these kind of frequency, that the same frequency, like same number. So whoever is repeating highest number of time. So one more thing is there could be such combination, multiple such combination. So we have to find the highest such combinations, because we are looking for the highest number of rows that can be become the identical. So now what we can do is, now simply we can loop through this matrix and generate the this kind of strings, and in this hash map we can store them in a hash map with the character, with the string and frequency type. Okay, so see here what we will do is, let's say our hash map, so TTTF. So initially what we will store at TTTF, it would be like initially 1, right? TTTF would be storing here 1, its frequency 1. Then we will come here, so the TFTF. So TFTF also coming first time, so its frequency also would be 1. Okay, TFTF, this is also 1. Now similarly when we will come here, this is already existing, right? TTF, so its frequency become now 2. Now again this is TTF is already existing, so its frequency become now 3. So 3 in this frequency, in this hash map, 3 is the highest frequency. So 3 should be our answer. This is what I want to say. Now I will show you the corresponding code that will solve this problem. So you can see here, this is my code. So I just created this frequency map, which will be basically string and integer to park the frequency. We just did, right? These things, TF, and all those, we have to park the frequency of them. So then what we are doing is, like we are going with the string builder, because this is string operation, so we should go with the string builder. Then see here, then what I am doing is I am going through every row. Okay, so when I am going through it, see here we are taking this, like this is a matrix, right? So we are going for this. See here, we are taking every row from here in this matrix, and this matrix, what we are doing is we are creating this string builder here. Okay, so because for every row we have to convert it to the corresponding this TFTF form, like this. We came to this row, right? Then very first element we converted to T, and the opposite were converted to F, right? So we are doing, what we are doing is, we are going for every row and then converting them into this kind of a string, and then storing into the frequency map. Okay, so see here, we are taking every row. Let's say we picked this row. Then what we are doing, we are traversing through the every element of this row, and then we are checking here that if whatever row we are going through, whatever column in this row, okay, so whoever is very first, so current row at 0, right? Okay, so whoever is that same value, we are anchoring that as T. So that is why I am doing pattern dot append T. Otherwise we are going for F, just like we going here, not this, sorry, this one. So first value here 1, so B appeared here, so T, and this guy F, right? So same logic we are doing here. Okay, so after doing this, we will have our, this pattern would have this string, corresponding string for the every row, right? So what we are doing is, now we are converting that into string, because so far it was string builder, and then we are putting it into the frequency map. So if it is already there, then we are putting with value 0. Otherwise, yeah, by default, otherwise we are just putting basically frequency, increasing it. Now what will happen, finally what we are doing, when we are coming out of this loop, we are going through this loop, right? This frequency map, and looking for all the values. Okay, so in max frequency, I am parking the maximum value, because we need the maximum one. So this will have the maximum rows that would become the identical after doing all this operation. We are returning this max frequency. So let me execute my code. So I am executing it. Let me try to submit it. Yeah, so it is working fine. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.